Now, the compiler tries to take the benefits of the high-level, loosely typed, very rapid prototyping nature of the Wolfram language, and allow you to then write code in that, but get the benefits of performance of compiled languages. So you mark up your code with typing information. This is going to be a real 64, and it's going to take that and look at your specific hardware. So not just that I'm on Windows, but I'm on Windows with an Intel such and such chip, and compile optimized code that will run directly as assembler on the chip for very fast execution. That's the basic idea. Now, it's very much been a sort of coders thing. If you kind of come from a C background, this kind of stuff is really familiar. One of the biggest things we've done here is actually write a proper tutorial now. So it was documented in how the functions work. But if you're wanting to understand all the concepts, we now have what amounts to a small book on how to use the compiler. So if we jump into some random thing like here, generating raw low-level virtual machine code, there's a narrative here of how that works, what you do, and there's some pages on LLVM. So you see the whole thing adds up to a couple of hundred pages. So now if you want to get into this, the onboarding is much simpler, and that's been quite a significant effort. If you're not one of those people, let's jump to some functionality. And I haven't loaded the compiler, which is still an ongoing project to make the compiler itself load and compile faster. But it is loading here. So this will be slow the first time, but the second time it will be much quicker. But let's explain what this thing does. So typically when you write a piece of code, it runs and it finishes and then you're done. But there is a program paradigm, which is sort of incremental functions that you run and you interrupt at some point. You get some value out, but you want to have a preserved state. You don't always work to get into this state. And you want to go back to it later and say, now give me the next answer, or compute more on this solution and give me another iteration. So while some of this is kind of compiler infrastructure here, function compilers using compiler, here's the typing. These are features of the compile only. The two new things here are incremental function, to say it's one of those functions. That takes care of all of the bookkeeping. And incremental yield, which is how we say when we're going to stop. So my raw code here is while true, so an infinite loop, take some number and add to it another number. So ordinarily that while statement would be an infinite loop. It would just keep adding num over and over again, and this mul would grow and grow and grow. And maybe I'd have some stop condition, it would stop and we'd be done. But by saying incremental yield, it'll suspend that. And I already compiled it. I've compiled it again. So I'm going to make an instance of that. Add number is our incremental function, and I'm initializing it with 7, which is going to be our num. And we created a data structure. And now when we say next, it'll run that until it hits its incremental yield, and it'll yield the result. So we added 7 to 7, we got 14. If I do next on the instance, I now pick up where I left off and get back 21. Now, you could do this in the Wolfram language before with global variables. But you'd have to think, well, what variables do I need? What's the state? I'd have to have some code that says, if this is a new instance, then create the state. If it's an old one, store the state in $global state or whatever. And then we've got to worry about what if I have 2 instances of this. So I'm going to create a second instance, which is adding 3s. And now if we run this, we'll see each instance adds 3, but my original instance 1 is still in its state of 21 and is adding 7s. So we'd have to worry about how to make global variables that store the values. We'd have to think about how to pick up the values, how to continue. All of that's handled automatically by virtue of the wrapper and the yield. So certain things where you're kind of wanting to find the next state of something, or you want to do further work on something, are now really elegant to program within the compiler framework. So that's just a kind of nice programming paradigm.